In this lesson, we're going to continue to look at the dot and cross diagrams for various simple molecular structures. Now, if you look at the periodic table here, you can see the principal elements which are held together by covalent bonds. These are elements that you come across in your GCSE or IGCSE or high school chemistry courses, and these are all held together by covalent bonds. Now, you'll also be aware that the group 8 elements are noble gases, they're inert gases, so they only exist as a single atom on its own. These have completed electron shells, so they're completely happy. They don't need to form bonds with other atoms in order to obtain a filled outer shell. The rest of the elements are metals and they all form metallic bonds. And along this boundary here, we've got what we call semiconductors. So they tend to have split personalities in a way. They're half covalent in nature and half metallic in nature. So they can be one moment non-conducting and in another moment they can be conducting. Now, going back to this group of covalent structures here, these non-metals that we've highlighted here, of these, the following all form what we call diatomic molecules. So we have iodine, bromine, chlorine, and fluorine. Those are the halogens. And we looked at their structures in the last lesson, how these diatomic molecules are held together. And then on top of that, we've also got oxygen, nitrogen, and finally here, hydrogen. Now, we're going to look at the covalent structure of carbon in the following lesson, and phosphorus and sulfur, well, we're going to leave those at the moment. These are slightly more complex structures. You'll notice that carbon, phosphorus and sulfur all are solids, and also iodine is a solid. Then you've got bromine is a liquid, and then chlorine, fluorine, oxygen and nitrogen, hydrogen are all gases. Now, in this lesson, we're just going to have a look at the dot and cross diagrams for oxygen, nitrogen and hydrogen. As I said before, we looked at those for the halogens last lesson. So let's have a look at hydrogen. Now, we know that hydrogen is the first element in the periodic table that just has one electron. And this is the 1s shell. And in order for hydrogen to be happy, it needs to complete that shell. This shell is completed with only 2 electrons. So it just needs another electron. Now, what these elements do is they form covalent bonds so that they can feel like they have completed shell. So in order to do that, they will share their electrons with another atom of the same element. So this hydrogen atom shares its electron with this hydrogen atom, and as a result, this hydrogen atom thinks or feels that it's got a completed shell. This hydrogen atom thinks it's got a completed shell. They're both happy. So we can write down the bond diagram. There are 2 electrons are used to form each single covalent bond. So we can write the bond diagram as that. And of course the formula is a diatomic molecule. We'll write it like that, H2. So next we'll look at the oxygen atom. We know that oxygen's in group 6, so it's got 6 electrons in its outer shell. Let's draw those. And in order to get a completed or filled shell, it needs 2 more electrons. Now, in order to do that, it's going to share 2 of its electrons with another oxygen atom. Right, so we have, it shares 2 of these electrons, and the other oxygen atom shares 2 of its electrons. And so this oxygen atom thinks it has, or feels like it has 8 electrons. This oxygen atom feels like it has 8 electrons. And you'll notice that in this case there are 4 electrons that are being shared altogether. That's to say, each is sharing 2 electrons. So in this case, the oxygen atoms are joined by 2 covalent bonds. So we can write the bond diagram for oxygen as a double bond, okay, with the formula O2. Now in the case of nitrogen, we're in group 5, so nitrogen has 5 electrons in its outer shell. So in this case, it's going to come together with another nitrogen atom. It's going to actually share 3 of its electrons. That's the only way it can feel like it has a completed shell. So this nitrogen atom shares 3 electrons, 1, and this nitrogen atom will share 3. Now, as with oxygen, nitrogen requires 8 electrons to fill its outer shell. So by sharing these electrons, this nitrogen feels like it now has 8 electrons, this nitrogen feels like it has 8 electrons, and they are happy. So you've got a total of 6 electrons being shared there. That's going to be 3 covalent bonds. So we're going to write the bond diagram in this case as N, okay, with 3 covalent bonds. Now we call this a triple bond. Again, the formula will be N2. All 3 of these are diatomic molecules, but the number of bonds involved in each case is different.